Question 6a. Phosphine pH3 and the carbon monoxide CO. They are monodentate ligands. Okay. As you can see, there is a lone pair on the this phosphorus and the lone pair on carbon. Means this lone pair will form dative bonds with the transition this metal cation. Now, all this answer, okay, in the part 1, 2, 3 is exactly for mark scheme. So it just if you know and understand that, so you actually can skip this part, right? So for part 1, define monodentate ligand. So the key is the species that donates one lone pair. Because it's monodentate, so it just will donate one lone pair and form one dative bond. That's we call monodentate ligand. So the key is donates one lone pair. For the part 2, define transition element complex, means the complex ion. So not transition elements, don't misunderstand that. So it's a transition elements complex. For example, like this copper complex ion, okay, with these few ligands. So it's a transition metal ion that bonded to one or more ligand. It can be one ligand, okay, like this example, just H2O, or it can bond to more ligands, right, 2 or 3 ligands. It depends. So this we call transition element complex ion. Explain why transition elements form complexes are. So it's actually related to part 1 just now, because it's accept the lone pair from the ligand and form dative bond. So the place to accept the dative bond is the vacant d orbitals. Actually, it's the hybrid orbitals, but you no need to know so deep. So you just need to remember vacant d orbitals, because there is empty orbitals or these vacant d orbitals. So therefore, it can accept the lone pair from the ligand and form the dative bond. For part B, okay, this one I'm not going to go through one by one with you, so you can read it. Okay, the first 3. Now, I need to, we just discussed this one, right? So for the diene, this one, the diene, so all the 3 bonds are lie in the same plane. So diene is a ligand that forms 3 bonds with the gold ion. So therefore, okay, here you must make sure these 3 bonding, they must be in the same plane. Means when you draw the complex ion, you have to follow this one. And the CO ligand coordinates through the carbon atom. Means the carbon will be the donor atom actually. This is the meaning. Means when you draw, you must draw something like this. Means the dative bonds is actually point to the C, not O, because you see that is through the carbon atom. So these are the 2 you have to you need to understand and be careful. So now, okay, table 6.1. Table 6.1. Complete this table and state the geometry of the first 3 complex. In order to answer this, you need to know how it looks like, of course. For example, like this, the first complex ion. So the metal ion is bound to the 2En. This is the bidentate ligand. This one. This bidentate ligand has 2 donor atoms. So we call 1,2-diaminoethane. So it has 2 donor atoms and it can form 2 dative bonds. So means now this metal cation, it's going to form 4 dative bonds with the En, because En now in this complex ion has 2. So 2 times 2, so is 4 dative bonds. And another 2 dative bond is from chloride. So therefore total is actually 6. 6 dative bonds involved, means 6 coordination number. So we are quite sure that when it's 6 coordination number, it's going to be octahedral. Square, planar and tetrahedral is just 4 coordination number. So the geometry for this is the octahedral, which is something like this. And this one is the trans isomer of the first complex ion, because the chlorine, okay, now they are at opposite side, means the bond angle between them is 180. So it's not the same side, it's at different sides, opposite side. And for this complex ion, actually it can form cis also, the cis isomer, something like this. So means now the chlorine, now they are actually at the same side, means the bond angle is 90 between them. So, and this cis isomer, actually it can form another one, the optical isomer, means it will form a mirror image, which will not, means that they are not superimposable. Okay, and now for this second complex ion with 2 CO and 2 chloride. So this one, because I already told you that the carbon monoxide is monodentate ligand, and the chloride also monodentate ligand. So means it will form 2 dative bond here and 2 dative bond. So total is 4 dative bond, and the coordination number is 4. 4 coordination number, it just can be square, planar or tetrahedral. Because in this table, it's already told you isomerism shown, means it can either form the cis trans, or we call geometric, and this optical isomerism. So since this one it has 4 coordination number and it can show this isomerism, we are quite sure this complex ion is square planar. Okay, so it's something like this, this one. So it's a square planar, means when the CO, they are at the same side, so this one is a cis isomer. When the CO, they are now at different side, opposite side, so this is a trans isomer. This is the isomerism that's shown by this complex ion. If it's a tetrahedral geometry, then it will not show this isomerism. So therefore, in this complex ion, the geometry, it must be square planar. So for this one, the third one, so the goal now with diene is this tridentate ligand. So it will donate 3 lone pair and form 3 dative bond. And H2O is monodentate ligand, and 2 H2O inside this complex ion, so it will donate 2 lone pair, form 2 dative bond. And it says chloride. Chloride is monodentate and it's just 1, so it's form 1 dative bond. So total 6 dative bonds form, so 6 coordination number, and we know that it's going to be octahedral, something like this. And again, when you draw this, you need to make sure the N must be same plane. These 3 bonding means go with these 3 N, they must in the same plane. So if you can see, this is the plane. This is the plane. Okay, so this part's done. Now part 2, use this complex ion, this one, okay, and this complex ion to write the equation showing the ligand exchange. So this one is actually asking you to to form this complex ion, means the goal with the diene and the 3 chloride. Okay, means use the first complex ion to form this second. And from here we can see that the first complex ion has 2 H2O. After the, let's say after the exchange, the H2O is eliminated, so it's being replaced. So we are quite sure the H2O here, the 2 H2O, is exchanged with the chloride. So here on left hand side we have to put 2 chlorides there, which used to replace or exchange with the H2O. Then the H2O will being substituted or being exchanged, and it will form this complex, this complex, the goal with diene and 3 chlorides. Part 3. Draw the 3-dimensional structure of the goal with diene and 3 chlorides. So this one is actually like is no charge now, so means no need to put the square bracket with charge. Okay, the diene ligand you can just draw like this, the 3N like this. So first, because we know that it's octahedral complex, so already given 2 normal line, you just draw the 2 wedge lines and the dotted line. This one is to shows that is to the front, and this dotted line is to the back. And you need to make sure the N means the go with all these 3 N, they are in the same plane, this plane, same plane. Okay, this is the requirement. After that, you complete with the chlorine. So after you draw this, then you just draw the 3 chlorines. Okay, and this is a complex that form. Right. So not difficult, right? So you just need to practice. Okay. So follow what I did here, and you know how to do. Draw the 3-dimensional structure of this one, nickel with the phosphine. This is monodentate ligand, already told you just now. And 2 chloride. So means this one is it will form 4 dative bond. 4 coordination number is going to be square planar or the octahedral. Sorry, the square planar or the tetrahedral. And let's get back to the table, see what is given. So this is the complex that asked. So in this table, okay, it's telling us that no isomerism shown. So means when no isomerism, we are quite sure this is not the square planar. If it's square planar, then it will show cis trans. So from this information, we know that this must be tetrahedral. So what you need to do is just draw the tetrahedral with the 2 phosphine and the 2 chloride. Okay, draw 2 normal line, 1 wedge line and 1 dotted line. So you just put the 4 groups there. Right. So again, no isomerism shown. So means it cannot form cis trans. Therefore, it just can be a tetrahedral. For the part 5, so one of the complex, so this one with 2 En, so means 4 dative bond, and this one with 2 chloride, so it's 2 dative bond. So total is 6 dative bond, and it will form octahedral complex. And this one has 2 CO and 2 chloride. This one to form 2 dative bond. This one also form 2 dative bond. So coordination number is 4. Okay, so it can be It can be this square, planar, or tetrahedral. Okay, and this one can exist in this 3 isomeric form. If we compare these two complex ion, we know that, okay, if this one is a square planar, the second one, this complex is a square planar, it just can form cis trans only. Okay, as I told you just now, it cannot form the optical. This one can form cis trans and the optical isomers because it's octahedral. So how to get these isomers? So the trans isomer is look like this one. The En, we better discuss the chloride. So the chloride now, they are actually at opposite side. So this is a trans isomer. When the chloride at the same side like this, so this is a cis isomer, and same side means the bond angle is 90. So this one is a cis isomer, and this cis isomer actually can form the mirror image. And both isomer, okay, they are non-superimposible. So this one, therefore, we call them as enantiomers or optical isomers. Means it will show optical isomerism. How to look at it? You have to at least pay some like imagination. I tell you roughly how to do it. If let's say now we try to rotate this chlorine or these two chlorine, rotate 180 degree, and we let this chlorine now at this position. So means this chlorine will at this position, isn't it? So again, we want to rotate this chlorine, okay, 180 to this position. Therefore, this will be the isomer after rotation. As you can see, after it's rotate 180, the chlorine position, okay, on the this mirror image, right? So this chlorine and this chlorine now actually they are same orientation, but the En is not the same. The En in this mirror image is at the back, and this one is actually in front. So means after rotate, it's still not the same thing. Means is the optical isomer. When it's not the same thing, means they are isomer, and because they are mirror images and not superimposable, we call them as optical isomers. This is how you get the optical isomers from these octahedral complexes. So we are quite sure, again, the one that can form the 3 isomeric or 3 isomers is the first complex ion, means the one with 2 En and 2 chloride, the octahedral complex. Right, so this one. Okay, so for the part, this is this last part. Okay, part 6. Draw the 3-dimensional structure of the 2 isomers of this nickel with 2H2O and 4 ammonia. So this one, they are all monodentate. So this one form 2 dative bond, this one form 4 dative bond. So it's going to be an octahedral complex. So you can actually draw the cis trans isomer. So make sure we use the water as the guide. So when the water ligand or they're at different site, so this is a trans isomer. When the water at the same site like this, so this is a cis isomer. Okay, remember to put the charge here. So since this one just can form the cis and trans isomer, so the type of isomerism that showing is the geometric. Actually, you can put cis trans. So geometric is actually cis-trans isomerism. Right. I hope you understand. Okay, and thank you.